Best money spent. 1.6b, we're going to do some absolute value inequalities today. Are you ready? Absolute value inequalities. So greater than, less than, or equal to, stuff like that. You've already done inequalities this chapter, but we haven't done absolute value inequalities. And these are a little tough. This is probably the hardest lesson in the chapter, so make sure you pay attention. All right, here we go. First part, part A. We're going to do equations that look like this. The absolute value of some stuff, right, x, or it's going to be 2x plus 3, something inside of there, we're going to do is less than a number a. Okay, now the absolute value makes it kind of different. So let me give you a quick, easy example. Do you remember when we had the absolute value of x is equal to 5? Right? We did this on Friday. And so we got two answers. We got x could be what? 5 or negative 5, right? And if we were to plot those answers on a number line, it would be a solid dot at negative 5 and a solid dot that's a positive 5. Those are your two answers. Those are the only two things on the number line that will work. Now, today we're going to talk about what happens when we have the absolute value of x is less than 5. Okay? So, I want you and I to think about some numbers that would work in that inequality. Okay? So, like, give me an example of one solution. Give me one number that works in there. 4. Perfect. 1, 2, 3, 4. 4 works. What else? 3. 3 works. 2. 1. Negative. 0. Negative. 1,000. No, negative 1,000 won't work. Take the absolute value of negative 1,000. What do you get? 1,000. Okay. So, negative 2 does work. So let's figure this out. How far does it go? It's going to go all the way to negative 5, but not include negative 5. Okay, and then it's going to go all the way up to positive 5. I'll do it in different colors. And it's going to be all the stuff in the middle. Yeah?
So if you said 1,000 and the absolute value of 1,000 is negative 1,000, isn't that?
No, absolute value of 1,000 is positive 1,000. Yeah. The absolute value makes everything positive. And I think of it as the absolute value is the distance from 0. Have you ever heard of that before? Yeah. So, like, let's say here I am, and I'm walking with my children at Sam's Club, because we always go to the club on Friday nights. And let's say I say to them, you cannot go up this aisle more than 5 feet away from me at a time, because then you're crazy and you're off, like, opening packages or whatever. So that means they could go a distance of 5 that way, or they could go a distance of 5 that way. Okay? So that's what this means. The absolute value is a distance from something. And so if it's less than 5, then it could either go to 5 positive or 5 negative and everything in between. All right, so let's do some of these then. Number 1. A lot of times people will think of this as this is less than and, kind of like it's and. It has to be greater than negative 5 and less than 5. It's an and statement, okay? So a lot of times people will think of these as and problems, less than and. So we're going to solve and graph. Solve and graph. So let's have letter A. We'll do 2 of these. Let's have an absolute value like this. The absolute value of 2x minus 1 is less than 9. Okay, so let's talk about what this means. If the absolute value is less than 9, it means that this stuff right here has to be less than 9 away, kind of away. So 2x minus 1 has to be greater than negative 9, but less than positive 9. It has to be in between, okay? And so this is the way you write it. You always write it this way. It's an and statement, so it's one whole thing. It's less than 9, which means it's greater than, this stuff is greater than negative 9, but less than positive 9 at the same time. And so you set up this equation for yourself to solve. And now you solve it. Let's add 1 to everybody. Add 1, add 1, add 1. So you get negative 8 is less than 2x is less than 10. Okay? and then divide everything by 2. You've already solved these last week. I think it was like Monday or Tuesday. Divide everything by 2, and you get -4 is less than x is less than 5. So numbers that are going to work in this equation up here that we just solved are going to be all the numbers between -4 and 5, including the decimals, and the pi is even an answer. Yeah, irrational numbers work. So if they ask you to graph it, you're going to go -4 and 5. And then you're going to ask yourself, is it an open circle or a closed circle?
Open.
Open, good. Does not include -5, and it does not, or -4, and it does not include +5. And then it's all the stuff in the middle. So there it is. There you go. Okay, so this is a less than. The absolute value is less than. The greater than ones are going to be completely different. So let's do another less than just so that we have it set. Here we go. Let's go with 2 times the absolute value of 3x minus 4 is less than or equal to 8. 2 times the absolute value of 3x minus 4 is less than or equal to 8. Now for these, and just like for our solving our equations, we have to get the absolute value by itself. We need to isolate the absolute value. So let's first divide everything by 2. You okay with that step? Were you thinking that before I said it? You're having some like algebra foreshadowing? Totally. All right, so now it actually is a thing. So we're going to go with the absolute value of 3x minus 4 is less than or equal to 4. Okay, think about this. This is going to be hard because we're going to flip the sign the other way and they're different. But when this is less than 4, you have to think that your stuff in here has to be between -4 and +4. It's like that. It's like your kid. Or, you don't have kids. I hope you don't. But like you're in like a china shop, right? And you're like, kids, you can't go more than 4 feet away from me. Then go that way and that way. Like you're in a line. Okay? Feet? Yeah, maybe inches, huh? All right, add 4 to everything. And so I get 0 is less than or equal to 3x is less than or equal to 8. And then divide everybody by 3. So divide by 3, divide by 3, divide by 3. 0 divided by 3 is 0. Here this turns into x, and this is 8/3. Okay. So the only numbers that are going to work in my original equation that was given to me way back up here are numbers that are from 0 to 8/3, but including 0 and 8/3 this time, because it's less than or equal to. It's the or equal to that makes it a solid dot. Do you feel pretty confident in your less than skills? Okay. Now we're going to do greater than. Here we go. So part B. When we have an absolute value that's greater than a number. So this is more like my speed right here. I get home from work and my kids are bothering me to make them snacks and dinner, and I say, guys, get at least 5 feet away from me, right? That's more like it. I don't need them all hovering around me. I want them to go. So if I'm standing right here and I say get at least 5 feet away from me, they have to go to 5 feet and get away from me. Or they go to -5 feet and they get away from me. Okay? So these turn out to be or problems. You're either less than -5 or greater than +5. So if I have the absolute value of x is greater than 5. Say the word greater, but go like this, greater. Greater. That's an or. I know we're kind of stretching a little bit, less than and greater, but it's helped people over the years. It really has. So this right here would be x would be less than -5. So all the smaller numbers going way down the end of the number line. Or x is greater than 5. And these are our or problems. So there's less than and greater. So what? Oh, you want to do some? Sure. Number 2. Someone said it. Maybe it was me. Let's go with solve and graph. And we'll do 2 of these also. Solve and graph. And you'll get the hang of them. And then you have some on your test. Quiz. Quiz tomorrow. Test Friday. Okay, here we go. Let's do the absolute value of 2x plus 4 is greater than or equal to 6? Oh, yeah. Sure. I'm always thinking absolute value is distance. If I have to be bigger than 6 away, okay, all this stuff right here has to be more than 6. That means this 2x plus 4 can be less than or equal to negative 6. So do you see how I flipped the sign for the negative? Remember when we divide by a negative number, we have to flip the sign? You can kind of think of that too, okay? And then I write the word or. It's not and, it's an or, greater. 2x plus 4 has to be bigger than or equal to positive 6. So less than or equal to negative 6, think about a number line. And here you are. If I want to go farther than negative 6, I'm way out here. If I want to go more than positive 6, I'm way out there. And now I have 2 things to solve. That's fun. It looked like one problem, but it's really 2. So let's solve. Subtract 4 to the other side. And you get 2x is less than or equal to negative 10. Divide by 2. You're dividing by a positive 2. There's no need to flip a sign or anything. Divide by 2, and you get x is less than or equal to negative 5. Okay, that's half the answers. Now let's find the other half. Subtract 4 to the other side. 2x is greater than or equal to positive 2. So x is greater than or equal to 1. So I put an or in the middle. These are both of my answers. Numbers that are, and we can graph this, numbers that are less than or equal to negative 5. Graphing it actually helps you see if you got the problem right. Did you know this is an or? It's going to go in either direction. Or x is greater than or equal to 1. If they're coming together, you did something wrong. It's not an and problem. It's a greater then. What do you think? You like these? I think I'm better at teaching these than I ever have been this year. I think I just did a killer job. It was amazing. All right, here we go. I should get a bonus, some kind of a salary bump for that. Yeah. I'm not going to hold my breath. Let's do this one. Do you want to try one? I think I'll do it with you. All right. 3 times the absolute value of 2x plus 6 minus 9 is greater than 15. All right. So write that down, and maybe you're confident in your math skills. You can probably figure this out. We need to isolate the absolute value before we do anything. And I'll have people that'll be like, oh, okay, it's less than negative 15, it's greater than 15. No. Don't even do that. We got to get this guy right here, all of this, all by itself before we do any of that. So we're going to, what's our first step? Yes? Yes, we do. We add the 9. Add the 9 first. Do not distribute that 3. You're not allowed to do that. So 3 times 2x plus 6 is greater than, what is that, 24? Yeah, 24. Now, what do? What do you got? Divide by 3. So absolute value of 2x plus 6 is greater than 8. Now, if you want to do that first step in your head, that's great. Okay, you're in Algebra 2 now. You can probably figure that out. Now let's set it greater than. So this is a greater problem. And when this whole thing is greater than 8, that means it could be smaller than negative 8 on the number line. Go way past negative 8. Or it could be greater than positive 8. So we flip the sign, and then we don't flip the sign. Okay, let's solve. Subtract 6. 2x is less than negative 14. Divide by 2. X is less than negative 7. Over here, subtract 6. Divide by 2. X is greater than 1. So I put an or in between, the box around it, and those are my answers. There's an infinite amount of answers here. You go to negative 7 on the number line. X is less than negative 7, so all the numbers smaller than negative 7. Yeah, sure. Or X is greater than positive 1. Okay, Any questions? These are tricky, I know. If you're like a little worried about this, and this is like the hardest lesson we've had this year, you're right. It is. They're a little bit tough, okay? There are a few special cases. I'm just going to run through them very quickly with you. So let me show you. There's 3 special cases with absolute value. If you have the absolute value, you saw this in number 14 in your homework last night. If you have the absolute value equals -3, okay, then you stop right there. And you say, yeah, right, no way. There's no way an absolute value can equal a negative number, right? It's just not possible. So you would say no solution. You could draw a circle with a line through it. No solution. We know that. So if you come across one on the quiz tomorrow, then do that. Okay? Don't solve it. People will. They'll go 2x plus 6 could be -3 or +3. You know, it's not true. Not true. Okay, now with absolute value inequalities, there's a couple of special cases. What if I change this problem to be greater than -3? Okay, what this essentially is saying is, when is a positive greater than -3? Always. So your answer is all real numbers. I always write it like that. You could write always. You could write all real numbers. Okay? It's true, no matter what. Pick your favorite number. Mine is 1003. Okay, it's not. Pick your favorite number, plug it in, it works. Your favorite number works. Your favorite number. Pi works, right? I always love to use pi. Pi always works.
What if our favorite number is negative?
That's fine. Plug it in. Like -100. Once you take the absolute value, it's back to positive. Okay, now, what about this? 2x plus 6 is less than -3. I see some people shaking their heads. Is a positive number ever going to be less than a negative number? No, never. Okay, so this one, no solution. So that's 3 special cases. This one had no solution, this one had no solution, but this one had all solutions. So when there's a negative on this side, you got to be careful and look for that.